Now, when you're doing programming, the trick with programming is to start at the outputs and work your way in. So with a programming, you start at the output and you work your way in. My thinking on programming is the easiest way to do programming is what I call the English sentence method. So you look at an output, you look at one of the lights, those lights are outputs. You look at one of those lights and you say, when do I want that light to switch on? And I write out an English sentence which is when I want that light to switch on. So, the sort of way this, and by picking special words out of that English sentence, it tells me how to do the wiring. Because the rules are, you write it out in English, and then you look for things called nouns. Nouns are objects. So nouns are things, well, they're real things, nouns. Every noun is a switch. And then you look for special words which are called conjunctions. Now, they just mean, conjunction means something that joins. Conjunctions are and or. Every time you write and or, that means it's a circuit. Whenever you write and, you wire things in series. Whenever you write or, that means we're going to wire things in parallel. Now let me see if I can show you how this works. We're going to look at some things called truth tables. And truth tables is how we explain how things behave when we wire switches together. Now the first one we're going to look at is and. And is two switches in series. So I have two switches. I have a switch called switch A and a switch called switch B. And I've written down in this table, it's called a truth table, every possible combination of these two switches. Right, so there's every possible combination of the two switches is in this table. Now, what I'm going to do is I'm going to go through these one at a time. Let's look at the first combination. Switch A is off and switch B is off. So I'm looking at this line here. Switch A is off and switch B is off. Both of those switches are open. What do I get as an output? I've got a relay on there. What does that relay do when both those switches are off? Yes, that relay is off. Okay, next one down. Switch A is off and switch B is on. What's my relay? Yeah. Okay, this is pretty easy, isn't it? Next one on. Now switch A on, switch B off, and my relay is off. And the last one, both of the switches are on. Yes, we're on. We have a symbol for this, and that symbol looks like this. Looks like a boob. Now, the English language for this is the output comes on when input A and input B are on. Input A, that's a noun. That's a switch. Input B is a noun. That's a switch. And we have the special word, the magic word, which is and. And tells us we wire in series. So if you write out the English sentence, input A comes on when, the output comes on when input A and input B are on, it tells you we've got a switch called A, we've got a switch called B, and we've wired them in series. So writing out the sentence helps us build the circuit. We also have this thing which we call a not and. It's a not and. It's a bit along the lines of Borat, who you say, who said, I like you lots, not, It's not means the opposite of. And we have this thing called a not and we abbreviate that to NAND. Not and is basically whatever the and does, the not and will do the opposite. I create a not and by taking a normally closed contact off the and. And now the not and, or the NAND, will be the opposite of whatever the and is. So the circuit looks like this. Okay, so we all good with this not and? Okay. So English language tells us which switches we've got and how to wire them. Let's have a look at the OR. OR means two switches in parallel. The output comes on if input A or input B. So we have two switches called A and B, and we have them wired in parallel. Because it says OR, we know it's in parallel. Okay, here is my truth table. Does anybody want to have a crack at saying what the sequence will be? Yeah. Some of you have obviously done this before. The sequence will be this: off, on, and off. The output comes on if the first switch or the second switch is on. Just like with the AND circuit, we have a NOT OR circuit. The AND had the NAND, the OR has got a NOT OR, which is called a NOR. And the truth table for the NOR looks like, oh, you've done it already. The truth table for the NOR looks like this. Whatever the AND is, the NOR does the opposite. Now, the symbol for a NOR, the symbol for an OR looks a bit like a more sort of curvy boob. Whenever we knot something, it's a boob with a ring in the end. Bit too imagey, that, really. Anyway, so we have got the OR. The OR is the two switches wired in parallel. OR means in parallel. Okay, are we happy with the English language and OR? Right. Okay, I'm just trying to change something here. Okay. Right, moving right along. What I want to consider, though, is the first output, which is going to turn a little red light on whenever... Oh, it says fan alarm. I don't know why it says fan alarm. It should say pump alarm. How's that? I've never seen that before. Let me just change that. Okay, the first output I want to turn on is the little red light. Oh, it should be red. The little red light which will come on whenever pump X goes into alarm. To make this decision, I have two inputs I'm going to check. The first input is the auxiliary on the contactor. The second input is the CT, which tells me that the fluid is flowing in the pipes. So I have an auxiliary on the contactor and a CT flow switch. Right. Considering the truth table for this, the first one, this line, so my contactor is switched off and there is no flow. Is that normal or alarm? So I'm not trying to switch my contactor on, and I have no flow. It's probably not between the hours of 9 to 5, night time, when I'm not trying to run my pump. So I've got no contactor, no flow. Normal or alarm? I reckon we'll go with normal. So the light is switched off. Second one. This one here. My contactor is not switched on, but I'm getting a flow. So I've not closed the contactor, but I've got stuff flowing in the pipe. Yep, now that doesn't sound right at all to me. That's an alarm. I'm not sure what's occurred. Maybe my contactor is welded shut and my pump's happily single phasing right now. But one thing's for sure, it's not right. Third option. My contactor is closed, but I have no flow. Contactor's closed and there's no flow. Yep, that's an alarm as well, because obviously my pump's not running. And finally, the fourth one, the contactor is closed and I've got a flow. Normal or alarm? Yes, that would be perfectly normal. I've told it to run and it has run, so that's good. Now, this pattern that we create here, this 0110 pattern, that's a special pattern. We use it whenever we're doing pump or fan alarms. In fact, any alarm where we're outputting something and then checking to see if it works. Sometimes it's called the mismatch alarm because it comes on when the two are not the same. It has a special name. It's called the exclusive OR. It's called an exclusive OR, and it has a special symbol which looks like this. Now, it's called an exclusive OR because the output comes on when one of the inputs is on by itself, exclusively. It doesn't come on when both of the inputs is on. So it's called the exclusive OR. And if any of you are wondering what an exclusive OR is, it's one that will kiss you on the lips. Okay then. Lost where I was there. Right, so my first output needs to create this pattern to be correct. I'm going to make an English sentence for this pattern. And the English sentence I make up for this pattern is that its output comes on when the auxiliary or the CT, but not when both of them. So this output, the alarm output, comes on when the auxiliary is on or the CT, but not when both of them. That's the English sentence I have. And I know that if I can make an English sentence, I can make a circuit. So, I'm going to just slightly rewrite that sentence as it's on when the auxiliary or the CT and not the auxiliary and the CT. Now, interesting words are being used there. Auxiliary or the CT. Or means two switches in parallel or series. Which is it? Or means two switches in parallel. So I've got a switch there and I've got a switch there. Two switches in parallel. Now the bracket over this side. Oops. The bracket over... Oh, get hold of that. The bracket over here. Auxiliary and CT. and means two switches in series. So by looking at the English sentence, I can see how to wire this thing up. So looking at this, I end up with this. I use a couple of internal relays. The first relay I put in place is the auxiliary or the CT. So I have a relay R2 which comes on when the auxiliary or the CT. I also want to do auxiliary and the CT. So I put another relay in, R1, which is auxiliary and the CT. And my English sentence read that the output comes on when I've got the auxiliary or the CT, and the auxiliary or the CT, that bit, comes from there. The auxiliary and the CT, that bit comes from there. Now what I'm going to do is I'm going to do this center bit. I've got another AND involved there. And I do it this way. That center bit creates that. Because R2, relay 2, is the auxiliary or the CT. Relay 1 is the auxiliary and the CT. I've taken a normally closed contact off of relay 1, which gives me a NOT. So that my output here, output 1 comes on when the auxiliary or the CT, and not both of them together. Now, I probably went through all of that a little bit fast. Luckily, all of this stuff is recorded, and you can go through it in your own time. Also, you get the chance to do this in your book. So I would suggest that you work through some of this stuff, you look at the recorded session and work through it in your own time. Is everybody happy for me to continue? Okay then. So what we've just done is we've used the English language sentence to build a circuit. That's how we're going to do all of our programming, not just relay logic programming, but PLC programming. All programming is done using the same method. You look at the output, you write down an English sentence which explains when you want that output to come on, and you look for the special words, and, or, not. They're special words. Whenever you see and, that means two switches in series. Whenever you see or, that means switches in parallel. Whenever you see not, that means grab the normally closed contact. There is another sentence that describes when this pattern comes on. Let me just refresh your minds with what the pattern looked like. It looked like this. 0, 1, 1, 1, 0, 1, and 1, 1, 0. Where that's A, that's B, and that's the output over this side. Okay? So the other sentence, another sentence that will describe when the output comes on, is that the output comes on when the auxiliary is on, but the CT is off, or when the auxiliary is off and the CT is on. That would also describe when the thing comes on. The interesting thing about this is, if you have two sentences that work, you will have two circuits that work. Here is the alternate circuit. And because the English language sentence works, the circuit works. So there is not necessarily only one unique answer. If you can describe it in English, you will build a circuit from the English. There may be more than one way of describing it. If there's more than one way of describing it, there's more than one possible circuit.